Now let's consider this standard index form. Under our standard index form, we can see that standard index form is a concise or short way of writing a very large and a very small number. When you have a very large number and a very small number and you want to write it in a short way, that's when you consider writing it in a standard form. And a number in standard form actually is written with this order or this form that we refer to as standard form. Then you're having a multiplied by 10 raised to power n. A multiplied by 10 raised to power n is the standard form. And in this case, we actually have where our a falls within this range of 1 less than or equals to a and less than 10. So that means a is a number that is, less than, I mean, greater than or equals to 1. It's also equals to 1 and it is greater than 1 and a is less than 10. That means the number of a fall within the range of 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the range where you have your number of a that falls in, as we have it here that a is a times 10 raised to power n. And now when you talk about your n, 10 raised to power n is the power of 10, where n is integer. Our n is integer here. And since n is integer, what this implies is that integer can be a positive or a negative counting whole numbers. It can be positive whole numbers or negative whole numbers. Now, a number written in standard form is also known as standard form. Instead of saying standard index form, we can as well refer to it as normal, the way we normally have it, as a standard. When you have a number in standard form, or you have to express a number in standard form, or we can also refer to it as scientific notation. Scientific, when you say you're having a scientific notation, that means you're having your number expressed or written in standard form. Now, for a large number, when you're having a large number, that means a number greater than 1. Now, n, when a number is greater than 10, for instance, n is positive. Where for the small number, now in the small number, when a number is very small, that means less than 1, like I said. When a number is actually greater than 10, that means when you have a number n and it's greater than 10, in that case, you are having your n to be equals to positive. Your n is positive. But when you are having the number that is less than 1, in that case, your n is negative. Your n is negative. And when you say a number is greater than 10, right from probably 11 until whatever number you can have, probably 20 digits number, 14, 80 digits number, whatever number it can be, your n is going to be positive. And when the number is less than 1, probably as far as you're having is 0 point, in that case, you're going to be having your n to be negative. And for example, we can have a number like, let's say you have 20,000, for instance, or let's say two tens thousand, two 10,000. Now, these two 10,000 can be written as 20,000. Now, how can you express this in standard form? We can express this in standard form by simply introducing a decimal point, and we move the decimal point. Let's say you have your decimal point here, and you move the decimal point 1, 2, 3, 4. And now that we have moved it this far, we are going to explain it further on how to get that. Then our answer is going to be 2 times 10 raised to power 4. You can see that because you have a number greater than 10. 20,000 is far greater than 10, so it's going to be a positive. And you have moved from where you introduce your decimal point in the left direction. Once you introduce your decimal point, you have moved in the left direction. And for you moving in this left direction, how many times do you move? 4 times. So that's going to be the power of 10. 10 raised to power the number of moves that you make, which is 4. And that gives you the answer in standard form. So likewise, maybe you have 1,000. For instance, you have 1,000. Now, in the case of this 1,000, how do you express this in standard form? You want to express this in standard form. 1,000, as we can have it, is 0.001. 0.001. So you can see that this number is less than 1. And if you want to move your decimal point here, you are going to move your decimal points in that direction like this. You are going to have your decimal points being moved from here. You are moving it 1, 2, and you move it here 3. So in that case, you can see that the answer is going to be 1 times 10 raised to power minus 3, because you have moved your decimal to the right direction, in the right direction 3 times. And that's why you have it as raised to power minus 3, 10 raised to power minus 3. So we are going to consider various examples on how we can express our number in standard form, and also how we can express the standard form in a number form. Now let's see what we have in this example here. We have this as the first example. We have example 1. In our example 1, the question we have, we actually say write the following, write the following, write the following, write the following numbers. You have the following numbers in standard form. You want to write the following number in standard form, in standard form. So you have the first number that we have here as 367. 367 can be written in standard form. How do you write it in standard form? We have another one, 9846. Oh, we have another one, C. We have 0.57. We have D, and that's 0.00437. Oh, that's fantastic. And we have, let me have this as a last number, that's 7. Now you can see now that in the first number, you have the number greater than 10. So there is no decimal. In decimal is not there. So for us to solve this question, or to see how we are going to solve this question, we are going to have the question being solved in this way. Now the first one we have there is 367. There is no decimal point here. So I'm going to actually introduce a decimal point outside here, and I'm going to move the decimal points 1, 2. Now when I move it 1, that number become 36.7. So when I move it the first time, probably I move it like this 1. So that number is 36.7. Probably times 10 raised to power 1. I move it once. Now you can see that this number is still greater than 10. So you have to move your decimal point again to this point. When you move it to that point, then it becomes 3.67 times 10 raised to power 2, because you have moved twice. So you can see now that in that case, the number is expressed as standard form in this way. So let me just write the number as 367. You have your decimal point and you move it 1, 2, and you have it here. So this makes the number to become 3.67 times 10 raised to power 2. That's how you express the number in standard form. Now we have the second number. Well, the second number is 9846. 9846. You want to express this in standard form. Now, how do you express this? Also, you can see that you don't have a decimal point here, which we are going to introduce. And when you introduce your decimal points, you move it how many times? 1, 2, and 3. And when you do that, you have your decimal point here. So that's give this number or this answer to be 9.846. times 10 raised to power 3 because we have moved 3 times. Okay, we have C here. Now for C, we have is 0.57. Now you can see that we have the decimal point here already. And how do you solve that since we have the decimal points here? So you are going to move these decimal points. You can see when you move it like this, the number become 5.7, which is within the range of 10. So in that case, it's going to be 5.7 times 10 raised to the power minus 1 because you have moved in the right direction. That is minus 1. And we have the next number, which is for D. For D, we have is 0.00437. Now, for us to answer this question, you are going to have it this way. You are going to move this number 3 times. You are going to move it 3 times. And for you to move it 3 times, you are going to see how you are going to move this. You move it this way 1, 2, and 3. So if you move it this way, the number become 4.37. And in that case, you are going to have it as 4.37 times 10 raised to power minus 3. That's your answer, as you can see. Then we have the last number there, which is our E, and this is 7. Now you can see that we are not moving the decimal. The number is just within the range of the standard form, but we can express this as 7 times 10 raised to power. Do you move anything? No, and that's 0. So this is also the standard form of how you write the number. Now, as you can see, the way you have expressed your number in standard form, and that's how we express number in standard form. And that's the first thing that we need to understand under logarithms, how to express a number in standard form. And we've been able to do that successfully here. Now we can also write numbers from standard form in ordinary numbers, and let's see quickly how we can do that. That's going to be the second example. We are going to express a number that is already in standard form in ordinary number, and let's see how we are going to be able to solve that question, expressing a number already in standard form in ordinary number. Now we have the question, and the question we have as it's this way, that we are to write the following number in ordinary number. That's the second example, and the question says that write write the following write the following write the following in ordinary number. Write the following in ordinary numbers. And how do you do that? We have the first question there is 5.8 times 10 raised to power 4. The second question there is 2.01 times 10 raised to power 7. We have the next one as 2.143 times 10 raised to power minus 5. And we have the next question, that's 7 times 10 raised to power minus 1. And the last day that we are going to consider is 3.001 times 10 raised to power 4. Okay, let's make this probably 5 times 10 to the power 5. Now, how do you express this number in ordinary number as we have been given the number in standard form? Oh, let's quickly look at that. Oh, see the solutions there. For the first one, we have 5.8 times 10 raised to power 4. Now we are having 4 here, meaning that we have moved our decimal point 4 times to the left. We have moved it 4 times to the left. So we are going to now write this, and this is going to be, you can write it this way: 5.8 times 10 raised to power 4, that's four zeros, 1 2 3 4 zeros, and this is just a decimal point, a digit after the decimal point. So you are going to move your decimal point back to where you have it here, and once you move it, it nullify or null or cancel one of the zero, and that makes it to become 5 8. Since you move decimal point one, it's cancel 1 0, and it remain 3 0 here, 0 0 0. So that's how you express that in ordinary form. I hope that is clear. And let's see how we solve another exam, the second example. Now for B, now I have 2.01 times 10 to the power 7. Now you can see here too, this is going to be 2.01 times 10 to the power 7. That means you're having 7 zeros. That's 1, 1, 2, 3, 4, 5, 6, 7. So you have to move this decimal point to make this number whole number, and that's going to be, you have it 1 and 2. That means you are going to cancel 2 zeros because you have moved your decimal point 2, and that's twice. Cancel each one you move, cancel and a zero here. So the number becomes 201. Then how many zero do you have left? 1 2 3 4 5. So you have your 5 0 here. 1 2 3 4 5. So that's the number in ordinary form. Now we have the next question, or the next answer that we want to consider. Now for C, let's see what we have for C. Here we have 2.143 times 10 to the power minus 5 times 10 to the power minus 5. Now the same thing we have. Now this, in the case of minus, and this is how it goes. Now you can see where you have your decimal point. You have moved the decimal point to the right direction. That's why you have minus. So we are going to move it back to the negative, in the next direction, and we are having minus 5 here. That means you are going to move it 5 times. So I'm having the number as, let me have it as 2.143. Then I'm moving the decimal point 5 times. 1, 2, 3, 4, 5. Now the other part that I'm having here, I'm going to fill it up with zeros. So here is going to be 0, 0, 0, 0. And once I have it this way, now I can write it out. It's going to be 0. How many zeros do I have here? That's 4 zeros. 1, 2, 3, 4. Then 2, 1, 4, 3. And that's the answer for that. So let's see how we solve the next one, for number D. Or for D, we have 7 times 10 raised to the power minus 1. And you can see here, just you have minus 1. That means you are going to move your decimal point once. So here is going to be 7. Then you move your decimal point 1. And that's why we have it as minus 10. So here you have your decimal point now. So the answer becomes 0 0.7. Is 0 0.7. And for E, we are going to have 3.001 times 10 raised to the power 5. So just like what we've been doing before, so we are going to write it out as 3.001 times, then 10 raised to the power 5 is 5 zeros. 1, 2, 3, 4, 5. Now, if you are moving your decimal point to the whole number, that's, you are moving it 1, 2, and 3. So that means you are going to cancel 3 zeros. 1, 2, and 3. So your number becomes 3001. Then you write the other two zeros, 0, 0. So that's how you write it in ordinary form. And you can see the way you have expressed and simplified the way to write a number, in from standard form to ordinary number, and also from ordinary number to standard form. Now we are going to see how we are going to solve our question, or consider the knowledge or the principle of logarithms of number, greater than 1. When a number is greater than 1, how do you go about it? What are the things that you need to understand? And how do you solve such numbers that are greater than 1 using logarithm table or using your calculator as we have it. Now, we have the fact that the most common used logarithm are logarithm to base 10, and we call this common logarithm. So in that case, we are actually discussing about logarithm of number greater than 1. Under the logarithm of numbers greater than 1, we have this logarithm of numbers greater than 1. Greater than 1. So how do you discuss the logarithm of number greater than 1? And like we said, when you are expressing or discussing this, you are going to talk about what we call common common logarithm. Common logarithm. And when you're talking about common logarithms, what are you talking about in common logarithm? Any positive number can be expressed as a power of 10. Any positive number can be expressed as a power of 10. And for example, let's say we have even 10. 10 can be expressed as 10 raised to power 1. And even when you have 100, 100 can be expressed as 10 raised to power 2. You have, let's say, 10,000. 10,000 can be expressed as 10 raised to power 4. And that's how we have it. This power of 10 are called logarithm to base 10. We call them logarithm to base 10. That is, we can have a number in this form. When you have a number that is logarithm to base 10, that's 10 raised to power of logarithm. Raised to power of logarithm. Logarithm of number can be obtained from four-figure table, as we know that we need our four-figure table to determine the logarithm of number when we are discussing the logarithm here. Now, how do you now look for the logarithm of number? How do you express your logarithm? To find the logarithm of a number, we need to express the number in standard form first and apply the multiplication law of indices. When you want to find the logarithm of a number, to find the logarithm of numbers, I'm just trying to logarithm of numbers. For you to find the logarithm of number, the first thing you have to do is to express the number in standard form. Express express the number in standard form. And when you are able to express the number in standard form, then you can now apply the multiplication law of indices. You apply multiplication law. We are going to see that in our example. Multiplication law of indices. Now, how can you go about that? For instance, you have these numbers that you want to find the logarithm. Let's say you want to find the logarithm of the number 850.9. 850.9. Now you can express this number in standard form, and when you do, you are only moving your decimal point 1, 2. So the number becomes 8.509 times 10 raised to power 2 times 10 to the power 2. Now, this means that this is our characteristics of the integer, that's 2 that we have here. Then, after you have done that, you are going to look for your logarithm table and find the value of log 85 under 0, and you had your difference. That's difference 9. Log 85 under 0, difference 9. You had your difference, or you press it straight away from your calculator. So it's very important to use the four-figure table to check your final answer and see how correct you are. So you can see this how to express this in standard form. After you have expressed it in standard form, you are going to find the log. The log of this number, that's 850.9. And when you find that logarithm of 85 under 0 difference 9, we actually have this 0.929299. So for you to express or write this, like we said, you have to find the logarithm of to have to express the number in standard form, then apply the law of multiplication of indices. And in that case, we are going to have this number. That means, therefore, we have 8509 to be equals to what we have, 0.9299, and that's going to be, oh, okay, you are going to express that in this way. We have it this way since you are expressing it in logarithm. So we are going to have it in this way. This is going to be 10 raised to power 0.9299 and multiply by 10 raised to power the integer, which is what, 2. And from there, we can say that this is equals to 10 raised to power, that's 2.9299. So the final answer for that is the logarithm of 8509 is equal to what we have here, and that's going to be 2.9299. And that's how you express your logarithm, or you use a logarithm just like we said, use a table, then you bring the characteristics to the logarithm that you have gotten, and that's going to give you answer. Now this is just for you to understand that these are the parts of logarithm that we need to understand. Note that in common logarithm, the base number, that is 10, is normally omitted. They don't indicate the base 10 when you are writing the logarithm. Is actually omitted. Now we have, the same logic that we have. For instance, a logarithm, the logarithm of a number contains two parts. It contains two parts, and the first part is called the integer. It's also called characteristics. The integer or characteristics. Now the decimal fraction part is called mantissa, which can be found from the log table. That's the mantissa can be found from the log table. That means I can rewrite what we have explained quickly here, that log 85 0.9, yes, is equal to 2.9299. And in that case, we are having the 2 as the characteristics, or the integer, while the 8 is the predicate. And we need to understand what that means. This is mantissa. This is the what we refer to as the integer. Why this is the mantissa. Mantissa. And that's just it. So we've been able to see how we can find the logarithm of number, and we are going to apply the same concepts to various examples as we go on.